All right, this is Module 17. We're going to be covering do-while loops. This is a continuation of last module's topics when we started looking at loops, being able to repeat the same set of statements or the same statement over and over again, controlled by a Boolean expression. So following along in the textbook, this is covered in section 5.3. And again, just like last time, let's motivate the problem just a bit and look at a particular program, very small, very simple, that could benefit from the types of loops that we're going to talk about today. So let me switch over to Visual Studio. I'm going to just talk about writing a loop that keeps asking the user to enter a number until they enter -1. So we're just going to read in a series of numbers over and over again, prompting the user for a number until they enter that -1. Okay, we'll get our main program up. I'm only going to really need one variable here. I'm going to read in integers, so I'll call it input. And just like whenever we start to write a loop, we probably want to think about what it is exactly that we want to do for one iteration, for one turn around the loop. So again, just switching back over to the problem statement, we're simply asking the user for numbers. And we'll probably want to tell the user how to stop the process. So -1 to stop. So that's the set of statements that we're going to repeat. Now, if I want to stop when the user types -1, what I could do is, coming from the last module, is just say while input is not equal to -1. And that would repeat over and over again until input is -1. So let's build that. And when we build it, we can see down here that we've got an error, uninitialized local variable input. So we need to understand what's wrong with this program so far. When we initially enter into the program, input is created as a separate variable. We certainly know that when a variable is created in this state, it has no data. Right? It's uninitialized. Essentially, it's garbage. The very next statement that we execute is this while input not equal to 1. The problem here, of course, is that input does not have a value. Right? So we're left with a little bit of a predicament. One way that we could solve this, and it's pretty straightforward, is to initialize input. And the question is, well, what do we initialize it to? Certainly, initializing it to -1 wouldn't be very helpful. It'll make the compiler error go away, certainly, but it's not going to really help us very much when we go to run this program. Nothing's going to happen. Right? And nothing's going to happen because input was -1, and we're looping around this while loop until that input is -1. So -1's a bad choice. We can choose literally any other value. 0 is perfectly fine, and the program would work. And so now I can type in numbers. And once I type in -1, that loop's going to stop. All right, so what's the problem here? The problem here is that we're sort of initializing a variable to some number that happens to work out in this case, but it's kind of awkward. And the reason it's awkward is that input really should be assigned by whatever the user types in. But we can't get this loop to start going around until input has a value in the first place, because we're checking to see whether or not these statements are going to execute before the user enters their first number. And that ultimately is the problem that we're really talking about today. So if we go back to the motivation part here, write a loop that keeps asking the user to enter a number until they enter -1. One of the things that should jump out to you is that the user can't type -1 in unless they type at least one number. So if we go back to Visual Studio, this set of statements must at least execute once. Right? It doesn't, there's no way that we can run this program and not have the user type at least one number. And that's a special type of loop. And it's a type of loop that the traditional while loop or the while loop that we saw in the last module really isn't designed for. Right? But luckily in C++ we've got a lot of different loop structures. So let's go back to the slides. And let's talk about the difference between what's called a pre-test loop and a post-test loop. In a pre-test loop, and a while loop is an example of a pre-test loop, we always check before we enter into the loop. So again, switching back to the code, we always check first the condition before we actually execute the code within the loop. In a post-test loop, we're always going to execute the statements within the loop at least once. Right? So the actual test, and if we look at the syntax down here of this do while loop, which is going to be our post-test loop, if we look at the syntax, we can clearly see that the test, the Boolean expression, happens after the first entry or the first turn around the loop. Note, there's a little bit of special syntax here. So instead of the traditional while loop appearing up top, this doesn't necessarily look exactly like an if statement. We've got the keyword do followed by a set of braces with a while loop afterwards, same Boolean expression, same kind of structure, same way we're going to structure our Boolean expressions, followed by a semicolon. Right? The semicolon is key. We are going to need that semicolon at the end of this do while statement. So switching back to the code now. If we use a post-test loop, I'm going to take out that while loop, and we switch this around. And notice that it's essentially the same structure. The first thing that we're going to do when we start this program is immediately ask the user for a number. So notice that input is not read, it's not checked, it's not used in our program until after the user types in a specific number, and then we actually check to see whether this test passes or fails. So in a post-test loop, we still have the same set of conditions. We're still going to look and see whether input is not equal to -1. And if this condition is true, we're going to turn around a loop. We're going to go back up to the top of that do while loop. Now, what this does for us is we no longer need this initialization. Input is not going to be read until it's actually filled in by the user. And if we build this without the initialization, we don't get a programming error. We don't get a compiler error. The program works exactly the same way as it did before, but we don't need to come up with some sort of an arbitrary input or an arbitrary initialization. And that's really ultimately what the do while loop is all about. It's the same basic construct as a regular while loop. It's just that now we do the test after the first iteration of the loop. All right, so let's get a little bit more practice with this. We're going to be looking at programming example 18. And for this, we're going to ask the user to enter a series of numbers, very similar to what we just did. We're going to stop by entering -1. And you'll notice that the -1 keeps appearing. We're going to eventually define exactly what that type of number is. But the additional thing here is that we're going to add in the logic to compute and display the average of all the numbers entered by the user. And we'll explain, the way we'll do this is through an accumulation problem. And if you look through the textbook, the textbook does explain what accumulation problems are. They're very common. They come in a lot of different forms, and we sort of have to think this through a little bit, and we'll get used to using accumulation in a variety of circumstances. So I'm going to go over to the whiteboard here, and let's just imagine that, how are we going to solve this problem first off? We're going to get a series of numbers from the user. So let me start writing. All right, so the user is going to enter in a first number, a second number, a third number, some arbitrary list of numbers. So let's say those are the numbers the user types in. We don't know how many numbers the user will type in. We're going to wait until they type in, of course, that -1 to stop. Okay? So the question now is, well, how are we going to actually get the total sum and then the average and anything else that the program's going to ask us, or the assignment's going to ask us to do? And one option would be, to store all the numbers in separate variables and to go ahead and add them. But again, if you look back at the problem statement, we really do not know how many numbers the user is going to type in. Right? All we know is that when they type -1, we need to stop. Right? So that presents a specific problem where there's no way for us to declare enough variables to hold each one of the user's inputs. The user's input is going to go into a variable, and we're going to have to, over time, compute the entire average or compute the entire sum. So the easiest way to do this is to start out with a variable. Right? Let's call it sum. And we'll start it out, perhaps with 0 in it. Right? So we can think about initializing some variable sum equals 0. The average, of course, when we're all said and done, the average is just going to be sum divided by some count. So presumably we'll also need a count variable. Whoops. Let's erase that. Okay. So we're going to need some count variable. Sorry about that. All right, so as the user, and let's switch colors here, as the user types in an individual number, we're going to read that number in, read it into a variable perhaps called input, and we're going to update the sum. And so if we erase this, as the user types in 3, sum becomes 3, count becomes 1. Next turn around our loop, we're going to ask the user for a number. The user is going to type in 4. And we're going to update our sum to be 7. And we're going to update our count to be 2. And we're going to proceed. When we get our number 5, we're going to overwrite this with 12. We're going to get our count to be 3. When we get our 2, we're going to get this to be 14. We're going to get count to be 4. And so each turn around the loop, we're going to have to add or increment sum by the number the user types in. And we're going to increment count. Once the user types in this -1, we need to compute our total answer. Right? So that's what we're going to do with this program. So I still have the same structure of my program. Now I'm going to have a sum variable, and I initialize that to 0. Remember, back when we were doing this over here, we started out with a sum of 0. We're going to also start out with a count equal to 0. And every time the user types in some input, we're going to increment the sum by whatever the user typed in. And we're going to increment the count by 1. All right, we can do plus plus, we can do plus equals 1, we can do count equals count plus 1. Certainly the easiest way to do that is just count plus plus. At the end, we'll print out the average, which is just sum divided by count. All right, so let's run the program and let's check our answers. And I'll type in 4, 5, and 6. And that's an easy test case because we know the average really should just be 5. We type in -1, and we get back an average of just 3. All right. So that's not right, obviously. We don't have the right answer. So whenever we see that we've got some wrong answers to this, the first thing that you should do, and I think I've said this before, start printing out information. Don't just stare at a number and try to figure out what went wrong. Print out all of your temporary variables, your temporary or your parts of your equations that you've built into your code. Right, so we don't like that average of 3. Let's see where that average is coming from. Well, the average is coming from sum divided by count first off. So let's print out some extra information. Don't really want this in the final program, but if we want to know what's wrong with average, we need to know what's wrong with sum and count, if anything. So we'll rerun this again. 4, 5, 6, -1. And we see that the sum is 14 and the count is 4. 4 plus 5 is 9, plus 6 is 15. Our sum is wrong. And our count, I only really typed in 3 numbers. Our count should have been 3, not 4. And hopefully you can kind of see what our problem is here. The main issue with our code is that the -1 has been counted. It's been counted as a real number that the user is going to use instead of just a number that signals that the user's done. So the sum, the -1, has been added to the sum. The sum was probably 15, and we can prove that, and I will in a second. And then it got decremented essentially by 1 by adding a -1. The count was incremented a 4th time to make count 4 turn out as 4. We can prove this to ourselves by actually printing out this information, not just at the end, but within each lap, within each turn of the loop. So sum is 4, count is 1, that looks good. Sum is 9, count is 2, that looks good. The 6, sum is 15, count is 3, that's perfect. -1, and now we can see sum is 14, count is 4. So that's our problem. Okay, so another aspect of this is how do we correct this problem? How do we start correcting problems in our programs? The rule of thumb, the thing that you want to keep in mind as much as possible is you want to identify the lines of code that are causing the problem and specifically correct those lines of code. Now that sounds very simplistic, and it sounds kind of obvious. If you're thinking along the lines of, well, sum is 1 less than it should be, count is 1 more than it should be, let's just make sum initialized at -1, and let's make count initialized at -1. Or actually, let's make sum, I guess, initialized at 1, and count initialized at -1. What you'll notice is that this does actually correct this problem. We get sum 15, count 3, average 5. So we've counteracted the problem by initializing our variables, sum with an extra value to it, an extra 1 set, and count sort of artificially drop to -1. And this allows us to increment and increment count and increment sum, but we're using that -1 the user types in. Now, if that was your first thought, or you're thinking somewhere along those lines, realize that while that works, it creates some awkward code. Another option would have been perhaps to artificially change sum later on. So a lot of people will keep the initialization there, but know that, well, sum needs to be incremented by 1 and count needs to be decremented by 1. All right? And again, that's going to solve the problem in terms of the final output. Again, we've got, oops, I think we need to fix this still, actually. Or no, actually, the sum is 14, count is 4. That's certainly wrong, but that's the last turn around the loop right here. And you can see the average did come out to 5 because we corrected for it. So if you had thought about either one of those solutions, if you had thought, well, let's initialize sum, let's initialize count a little differently, or let's fix sum or fix count later after the mistake occurred, you certainly could have gotten the problem right, but I would really caution you against that. Because in both situations, it's very unclear when you look back at this code later on in a month or so, it's very unclear why you would be doing this. Right? This would demand a comment. This would demand that you write something like fixing the sum with -1. Right? And same thing with count. Likewise, if you chose to change the initialization, again, if you were to look back at this code later on, this would be pretty confusing. Why would you start a count at -1? You'd need to write a comment. So instead of doing either one of those options, what you want to do, and I strongly encourage you to try to get into the habit of this, is to isolate the exact piece of code where the problem starts. When the user types in -1, sum plus equals input, count plus plus, ultimately should not actually happen. When a user types in -1, the -1 should not be added to the sum, and the count should not be incremented. We have in our power, we learned enough about C++ to say that those two lines of code could conditionally execute. They only execute at certain times. And in this case, that time is when input is specifically not -1. So the proper way to go about fixing this code is not to sort of rig the initialization such that you can make the mistake and it will kind of cancel itself out. Not to go fix it after it happens down here, but to simply say, if input is not equal to -1, increment the sum and increment the count. It requires you to use a little bit more C++ language, but it's far more expressive, and then it also has the added benefit that a couple months from now when you look back at this code, it's frankly quite clear as to why you have this input statement. You certainly don't want to count the -1. If we run this program, we'll see again we do get the right answer. When I type in -1, you'll notice that sum and count were not changed, and we get the average of 5. All right, so let's try one additional problem here. Let's type in 2, 3, -1. Our average is now again wrong. All right, the average comes out to be 2, and certainly 5 divided by 2 should have been 2.5. So this is our familiar problem, and something that's just so easy to creep into our programs that we're going to see it often, purposely or not. We're going to make that mistake in a lot of different programs that we go throughout the semester. But if we look at this, the reason we're getting 2 instead of 2.5 is that we're doing integer division. All right, sum and count are both integers. So 5 divided by count, 5 divided by 2 ends up just being 2. The simplest way to fix this is to make one of them or both of them, although count really should be an integer, make one of them double. And then of course now the user could type in 1.5 as well as one of their numbers and our program will work. So changing one of the operands in our division to be a double or to a float would fix that integer division problem. We'll do our test input again. And now we see the average is 2.5. At this point, we can go through and we can remove our temporary printouts because we've got the right answer. And we're left with our final piece of code. We'll run that again. We have our answers. All right, so let's review a little bit about what we've learned so far with loops. When we're working with user input, loops are very, very common. Typically, we'll let the user control when the program stops accepting numbers or stops doing a certain activity. Part of the difficulty with programming when you're first learning is trying to figure out exactly what constructs to use when you see a problem statement. And you want to try to start to identify patterns in the way problems are stated. So for instance, read in a series of numbers until the user enters -1. The moment that you see the word until, you should know that something's going to be continually happening until some condition occurs. The until part generally implies that you're going to need a loop. So when you see until in a problem statement, that's one of the first things that you should start to think of. You should start to think of whether it's a pre-test or a post-test loop. And we're gonna talk a little bit more about identifying those type of loops later on. In addition, whatever comes after the word until is typically either the entire test or part of the test to stop the loop. So in this case, the user enters -1. Certainly that doesn't translate directly into C++, but if we look back at our code, we know that the user enters a number, it goes into input, and there you go. All right, the test is while the user has not entered -1. Oftentimes, the logic goes a little backwards. Right? We're going to read in a series of numbers until the user enters -1. To put that into a while loop, to put that into a do while loop, we need to reverse the logic and instead sort of say to ourselves, we're going to continue to read numbers while the user does not enter -1. So sort of the opposite of the word while is until. Right? Until is usually followed by the condition to stop. The while loop itself really needs the condition to keep going. Right? And that's a really important distinction. Sometimes the challenges of taking a word problem that uses the word until is really just flipping that logic. It's not until input equals -1, it's while input not equal to -1. And that's just a limitation of C++. There is no until construct, there's only a while construct. In other languages, Ruby for instance, you actually have the construct until or unless that will allow you to do something like that. Finally, that -1. We've used it a couple of times now. The -1 is typically referred to as a sentinel value. It indicates that the user is done with their input. The sentinel could be any number. It could be -1, it could be 9, it could be 5, it could be 42. The important thing is that it's a known number. It's a number that you've told to the user to type in to indicate that they're done. It's a flag. It's not actually part of the data that the user is typing in. So -1 is very common, but of course if I was going to ask the user for a series of negative numbers, -1 wouldn't be a very good choice of a sentinel value because they might actually want to type -1 as their data. So perhaps if I was asking the user to type in negative numbers, my sentinel value could be 1 or a +1. Type in a +1 to stop or to indicate that you're done. So we have to be careful about picking that sentinel value. Normally, probably 95% of the programs that we do will use -1, but it's sort of arbitrary. It could be any number. Another great thing about do-while loops is input validation. So in the past, we've been able to ask the user for specific ranges of numbers. We've worked with relational operators to make this happen. We can ask the user specifically for a positive number, but we really haven't been able to ask them again if they've sort of messed up. So, if we were designing a program in previous modules to ask the user for a positive number, we might check, and we could certainly do that still. We could check to see if x is less than 0, and if it is, we could say, hey, you needed to enter a positive number, but we would have to stop the program. Right? There was nothing more that we could do. Now when we've got while loops and do while loops, we can ask the user for a positive number and then check to see whether that number was indeed positive or that number fit the criteria that we were asking for. If it doesn't, we can continue around this loop. Right? So this is a much more powerful construct, it's a much more user-friendly way of programming an application. We can ask the user for a positive number, and if they fail to do that, we can ask them again. The key part here is we always are going to just take that prompt and that input and wrap it in a do-while statement. Right? It should be a fairly straightforward process whenever we're doing input validation. Perhaps the conditions are going to be more tricky. Note here that I've used a do-while loop. A while loop doesn't make a whole lot of sense. And the reason a while loop won't make a whole lot of sense here is that it's a pre-test loop and we haven't read x. So if we said while x is less than 0, see out and enter a positive number, it's not very effective. All right, so let's try out another example. I'm going to have the user type in a series of numbers, and I'm going to print out the value of the square root of that number. So we in math, we of course can compute the square root of negative numbers using the imaginary numbers, but for our program and for the math library for C math with square root, we don't want to deal with negative numbers when we're dealing with square root operations. So what we're going to do is we're going to have the user enter only positive numbers, and I'm actually going to do some input validation on this and make sure that the user has typed in a positive number before I try to compute the square root. Now to add on to this, I'm also going to allow the user to type in a series of these numbers, and I will specifically stop when the user types -1. Now what's kind of hidden here is there really is going to be two loops here. One loop is going to control the reading of a continuous set of numbers from the user that are presumably positive until the user types in -1. There's going to be a second loop hidden in here that's going to do input validation to make sure that the series of numbers, that each number the user types in is indeed a positive number. I want to tackle one at a time. I don't want to combine these two concepts. Right? And when you set out to do a program and there is going to be input validation, for instance, positive numbers, generally it's the smart idea to leave that input validation to the last step. Right? And I'll show you exactly why, because the principal issue here is that it's a lot easier to add input validation after you're done programming than sort of in the middle of problem solving. So I'm going to transform this program a little bit and just simply say, allow the user to enter in a series of numbers until they type in -1, and each time they type in a number, I'll just print out the square root. All right, so I've got my exercise 19 project. We're going to use the math library to do our square root. The structure of my program will be very similar to the last exercise. I'm still going to have an input value, input. Maybe I could use double if I wanted to. The integers will be just fine for now. I'm going to start reading in numbers over and over again until the user types in -1. Again, that's going to be a post-test loop. The user can't type in -1 until they type in at least one value. So while input is not equal to -1, I'm going to continue around this loop. And each turn around the loop, I'm going to ask the user for a number. And I'm going to read that input. And before I even go any further, we might as well build the program, make sure that the loop is constructed correctly. Okay, so my build succeeded. We'll switch over to command prompt, P19, enter a positive number. I should be able to write numbers. Now, of course, if I type in -9, the program doesn't deal with that at all. Eventually, we should ask the user to specifically enter only in a positive number and handle that error. But right now, we just have it stopping at -1. All right, so next step. Let's print out the square root. So the square root will certainly potentially be a double. We'll call it value. And we'll call the square root function in CMath. And we'll give it the input. And we'll print out the answer, the square root of input is value. Right off the bat, we'll notice that we've got a little bit of an issue with our -1. And certainly still we're not handling our positive numbers. So 4, 5, 2, -9, and you can see the CMath library isn't really very friendly for us with the negative values. It's basically printing out infinity, and the same thing occurs with -1. Right? And the reason we're getting square root of -1 is some garbage value is because we're specifically asking for the square root of -1 when the user types in input. So it's not an accumulation problem, but again, that -1, that sentinel value, is again something that we want to work with, and we want to make sure that we avoid doing our main task. So if input is not equal to -1, we'll print out the square root. But if it is -1, we certainly don't want to do any of this stuff. So going back with our set, again, the positive number, we've asked the user for a positive number. They've typed in -9. That is an error condition. We haven't dealt with that yet, but you'll see now at least we have dealt with the -1. Right? The -1 was our stop condition, and we aren't continuing. So next we want to deal with, well, how do we deal with this -9? Right here, these conditions or these statements are what's accepting input from the user. I want to continue to ask the user for a positive number or the -1, right, until they enter something that I was expecting. So these two line of code is what needs to be repeated if the user enters in a value that's not acceptable. So I'm going to create another loop. I'm going to create a simple input validation loop around my prompt and my read. And all input validation loops look the same. We're going to have our prompt. We're going to specifically try to say in our prompt what we're looking for. So positive number, -1 to stop. So the user can type in a -1. And we're going to loop, and we're going to continue to execute those two statements while the input is not valid. So the trick to input validation is constructing a Boolean expression that is true when the input is not valid. So in this case, if I say input less than 0, that's not quite going to be right. It does say, well, if the input is negative, keep asking the user, and that is somewhat good. If we run this again, 5, 2, -9. Now notice that when the user types in -9, we don't yell at them, we don't say anything specific, but we simply repeat the same exact prompt. And if we read the prompt carefully, we've explained everything we need to explain. Enter a positive number, -1 to stop. Now if the user's done now, and if we type in -1, it still says enter a positive number, -1 to stop. And the problem here is that the expression for invalid input is also capturing that -1. So we could say while input is less than 0 and input is not equal to -1, that would work, right? So a valid number for the user to type in is something that's either greater than 0 or it's -1. If you look closely at this, we really don't need to do this. We can simply say input's less than -1 now. Either of those techniques would be perfectly fine. By the way, when you compile code, this will start happening a lot once you start dealing with loops. You may end up with an error, cannot open your particular exe for writing. That's usually indicative of the program still running. So I didn't actually stop the program. Again, Control-C, just like in an infinite loop, Control-C will stop the program. You can't compile successfully if the program's running. Right, so now we got the right answer. We got the compile result. So if I type in 4, I get 2. I type in 5, I get the square root of 5, 2.23607. 2 should be a little bit familiar. -9 just simply restates the prompt, so we don't actually get the error condition. And now when we get -1, we do stop. Just to prove things out, if we we don't necessarily have to stop after that -9. We could type in 8 and get an answer. Type in 16. We can type in -7 later. We can type in negative numbers forever, and we'll still be stuck in that do-while loop. When the user's typing these negative numbers that are not -1, we're stuck in this loop. We're stuck within this do-while loop. Once the user types in a value that's either -1 or positive, or 0 or positive, we're going to get out of this loop, and then we're going to evaluate this if statement. If it's not -1, we're going to print out the square root. If it is -1, we're going to continue down, and we're going to break out of our while loop. I want to caution you against, I certainly the first time you start looking at do-while loops, the idea of now nesting do-while loops, having a do-while loop within a broader do-while loop seems a little complicated. I want to caution you strongly against trying to embed or trying to somehow get this input validation, positive numbers, also into this while loop. They're two different situations. One situation is simply input validation. The other is looping around until the user's done. When loops are covering two different conditions, validation, are you complete, they should be two separate loops. It will generally be much easier if you write them as two separate loops than trying to combine them. So I went through a very specific set of steps to get this problem started. I started out with very little looping, very little input validation whatsoever. I gradually added a conditional execution around my square root computation, and then I added a do-while loop only specifically around the prompt and the user input. It would have been incorrect to do something like this. And that's simply because we don't know whether the input's correct at this point. The key part here is that input validation should be tightly wrapping the prompt and the user's input. And whatever happens after that really is of no concern of the input validation. All right, so for the lab today, what I'd like you to do is write essentially a guessing game. We've seen how we compute random numbers. I'd like you to compute a random number as the program starts out between 0 and 10, or between 1 and 10 if you want to do it that way. That's fine as well. Don't print it out. It's sort of a secret number. Maybe while you're debugging you might want to print it out, but that's up to you. After you compute this random number between 0 and 10, I want you to ask the user for guesses. And each time they enter in a value, determine whether that value is less than the secret number or greater than the secret number. And tell them whether their guess was too low or too high. If they get it right, say congratulations, and then they'll be all set. I want you to continue to allow them to guess until they get it right. And that's the until part is sort of implied here. They're going to guess over and over and over again until they get the right number. And of course, your information, the information in your program is telling them whether their guess is too high or too low. Should help them, zero in on this number that was randomly selected. I mentioned as a debugging technique, it might be a good idea to print out that random number so you actually know ahead of time what number that is, so you can test your logic. So once they guess it right, you're going to exit this loop and be done with it. As a little bit of extra credit, I'd like you can also sort of wrap this entire program in a continuation loop, where after the user guesses correctly, you let them play again without restarting the program. I'll let you kind of tackle that yourself, but you might want to look at some of the problems in the book that involve yes, no, continue examples. That'll help you along with this.